Yes, ma'am.
Bruh, bruh, bruh,
Bruh,
bruh, bruh, bruh, bruh.
bruh, bruh.
Okay, hi everyone, let's get started. Make sure you do your work here.
Yes, ma'am.
Good morning, Prof. I'm Irvin. Let me now introduce my group. Anastasia, Iliana, Emmanuel, and Lukman. And our team will actually be covering on the performance of hybrid work. So in the past few years, the shift to hybrid work has actually sparked the debate about how it affects both productivity and employee satisfaction. And while flexibility is widely appreciated, data-driven insights into the optimal remote office balance still remains scarce.
Okay, thank you, Irvin. Now we'll be talking about the central limit theorem. So that CLT states that the distribution of a sample mean of any distribution will become close to a normal distribution with mean and variance sigma squared over n when the sample size n is large, which is more than or equal to 30. Since our sample size is 200, we can apply CLT, making our sample mean close to a normal distribution. Next, for our hypothesis testing, we are testing to see whether the average working productivity from home is equal to that of working from office. So mu1 is the average productivity working from home, and mu2 is the average working productivity from office. So the null hypothesis is mu1 is equal to mu2, and our alternative hypothesis is mu1 is not equal to mu2.
Thank you, Anna. Now I'll be running us through the two-sample t-test. So the first assumption is that there's independence in two groups, where remote workers and office workers must be statistically independent. And they must also be identically distributed, where each sample point must follow and be representative of the distribution of the population of workers. So from our output, we found that the p-value is extremely small, which shows that our results are statistically significant. And it also shows that there's a very strong evidence to reject the null hypothesis. We also found that the sample estimates of mean from mu1 and mu2 are different, which shows that remote employees are statistically significantly more productive than in-office employees.
Okay, thank you, Eliana. So now we'll be moving on to the regression analysis, where we'll be looking at these variables and how these variables affect productivity. So for the code, we first have to load in the file, and then next we have to change remote days into a vector variable so that we can see how each additional remote day affects productivity. And when we run the code, this is the result, and we'll next be looking at the coefficient, standard deviation of error, t-value, and r-squared. So for p-value measures whether the effect of a variable on the productivity is random or not. So if we look at remote work, the p-value for remote work is extremely small, is lesser than 0.05 to be exact, and the ones that are denoted by 3 stars shows that it is statistically significant. So for remote work, 2 days and 3 days of remote work is extremely affects productivity heavily. And same for work-life balance, job satisfaction, and years at company. Next, we'll be moving on to t-value. So t-value basically shows us how strongly a variable affects productivity. So the higher the t-value, the stronger the evidence that this variable matters. So if we look here, same thing, for 2 days and 3 days of remote work, the t-value is extremely high. So that means that it matters more. Same for work-life balance and job satisfaction and years at company. So next we'll be looking at coefficient. Now coefficient basically tells us how much productivity changes when the variable changes by 1 unit. So for example, for 3 remote work days, right, there will be a 6-unit change in productivity. And finally, for r-squared and adjusted r-squared, we basically use r-squared to measure how accurate our model is. But why we have adjusted r-squared is because the model is filled with variables that don't really matter. And adjusted r-squared basically takes into account for these variables that don't matter, and hence it is a better indicator of how accurate our model is. That's why we use adjusted r-squared.
Thank you, Emmanuel. To summarize our findings, our analysis shows that remote days,
work-life balance, job satisfaction, and years at the company have statistically significant and positive impact on productivity through their low p-values and high t-values respectively. And among them, remote days shows the strongest effect, followed by job satisfaction and work-life balance through their coefficients respectively. Our findings further show that offering employees around 3 remote work days per week ensures optimal balance where we ensure flexibility while maintaining strong performance. However, not everything we tested was significant. Commuting time and company sector had no statistic significance on productivity. That said, our regression model currently explains 68% of the variation in productivity, which is solid, but there's still a lot of room to improve. To improve our model's accuracy, we suggest collecting more additional variables like meeting load, managerial support, and distraction levels at home. This helps us capture more real-world drivers of productivity.
Okay, let's get to work.
Yes,
Yes,
ma'am.
Oh, before we start, I have an announcement. Everybody will be having 3 remote days of work, so we're not gonna have staggered work days anymore.
No.
Oh my god, I can't believe it's happening!
No.
The best day of my life.
No.
Okay.
水能载舟，亦能覆舟。That means water can carry a boat, but it can also overturn it. To explain, it means something beneficial like remote work can help or harm depending on how it's handled. This speaks to the need for careful balance. Remote work is powerful, but only when supported by the right mindset and accountability. Thank you, Gamsamida. We have come to the end of our presentation. Thank you.